Hello everyone, welcome back to my channel. So this is our eighth session related to supply chain analytics, and today also we are going to solve an issue related to the transportation problem or the network problem. So if you remember this, in our previous supply chain analytics session, that is session number 7, we have discussed a similar type of problem. But here I have increased the complexity of the problem by adding some new criteria. So let me just go through the problem statement, and after that we are going to build the optimization model based on the requirement. Now, what is the requirement? What is the objective of this problem? Again, the objective is same, where to set up our plan so that we can minimize our cost and we can able to transport the material from the plant to the market destination in a lower cost, keeping in mind all these criteria that we are going to discuss now. Okay. So as we discussed in our previous session, that is session number 7, this is our source. Source means what? Where we are going to set up our plant. And these are our market or the destinations. Now source, we are going to represent it as I. Okay. And destinations, we are going to represent it as J. Okay. Now, to transport a material from USA plant to the market of Ghana, we have to spend around 50 rupees. Okay, so here you can see production and the transportation cost per unit. So to supply a material from USA to Ghana market, we have to spend around 50. From USA to China, it is 70 rupees. From USA to Nepal, it is 100 rupees. From USA to Sri Lanka, we have to spend 120 rupees. And from USA to Indonesia, we have to spend around 100 rupees. Similarly, you can also see if we set up our plant in Brazil, then what will be the cost? If we set up our plant in Denmark, in UAE and India, what will be the cost to transport the material from that particular plant to this respective markets? Okay, so this is the transportation cost, you can say. Now, these transportation cost, we refer them as a CIJ. What is CIJ? Cost of transporting from source I to destination J. Okay. Now, what is cap low and cap high? So basically, this is a plant with low capacity. Okay. So here we have segregated the plant into two different types based on the capacity. First plant is a low capacity plant, and there you can produce around 10 units. And this is a high capacity plant where you can produce 20 units. Okay. Now, what is the cost of setting up the plant? So again, we have segregated the data into two types based on the capacity of the plant. So if you set up a plant in USA, which is of the low capacity, then you have to spend around 6,000. If you want to set up a plant of high capacity, then you have to spend around 9,000 rupees for USA. Okay. Now, to build a mathematical model, let me write down some abbreviations. Okay. So here we are going to use KLI. Now, what is KLI? Capacity of small plant at source I. So KLI will represent capacity of plant, small plant at source I. Okay. Similarly, what is KHI? Capacity of large plant or big plant, whatever you want to say, at source side. Okay. Now, what is FLI? FLI will represent fixed costs, that is the capex of building a low capacity plant at source site. Similarly, FHI, it will represent fixed cost, high capacity plant. Now what? YLI, number of low capacity plant at source site, and YHI will represent number of high capacity plant at source site. Okay. And what is XIJ? XIJ is quantity transported from source site to destination J. Okay. What is YI? YI is nothing but the location variable. And if you remember this, in our previous session, that is session number 7, we consider this YI as a binary variable. Okay, that means in a single source, maximum you can create only one plant. But for this problem, we have increased the flexibility of the problem. Okay, so here we are not considering YI as a binary. Instead of that, we are going to consider YI as an integer. So what do we mean by YI as an integer? It means value of YI can be 0, 1, 2, 3, etc. Okay. Okay, now let me copy this one and paste it here. Okay, so here we can write it as YLI. What is YLI? Number of low capacity plant at source I. So basically we are going to find it out. What will be the suitable low capacity plant we can build in any one of these source. Okay, so that we are going to find it out. Similarly, we need to mention here YHI. Now, what is YHI? YHI is number of high capacity plant at the source site. So again, we are going to find it out how many high capacity plant we are going to build in any one of these source based on the requirement. Okay. Here we can change this as a total supply and available capacity. Okay, now before solve this issue by using the Excel solver, let's build the mathematical model. So here, what is our objective? Our objective is to find out a suitable plant location so that we can send our product to respective markets in minimal cost. Okay, so this is our objective. First of all, we need to find out a suitable plant location so that we can minimize our transportation cost while sending the product from the plant to the markets. And when I am saying the market, it means all the 5 markets. Okay, so if I need to write the mathematical formula for wave B, that will be I is nothing but the source. Okay, so Here we have 5 sources. So you can mention I equals to 1, I equals to 5, then FLI. What is FLI? That is the capex or the fixed cost of the plant, low capacity plant. So FLI multiplied with YLI. What is YLI? YLI is the number of the low capacity plant. So fixed cost of low capacity multiply with the number of low capacity plant. Similarly, we need to mention the same thing for high capacity as well. Plus FHI. What is FHI? Fixed cost for a high capacity plant multiplied with YHI. Okay. So this part will cover the fixed cost for setting up a plant. Fixed cost fixed cost to set up a plant. This is one part of the objective function. Now, what is the another cost? The another cost is the variable cost or the operation cost. Okay. What is the operation cost? The operation cost is this transportation cost will be our operation cost. So first of all, we need to take care that how much materials we are going to supply from which source. That will be our Xij. What is Xij? The quantity transported from source I to destination J. So that one we need to find it out. Second of all, while transporting the quantity from the source side to the destination J, there is a operation cost or the transportation cost. And now these are the transportation cost. Okay. So here we have mentioned the cost of transporting as a Cij. So that means we can say plus summation source 1 to source 5 source 1 to source 5. Similarly, destination J equals to 1 and J equals to 5. Cij. What is Cij? The cost of transporting the material from source side to destination J, and Xij. What is Xij? The quantity that we are going to transport from source side to destination J. So this part, so this part becomes the variable cost, the variable cost. Okay. So in our objective, we have mapped both different type of cost. First of all is the capex cost or the fixed cost for setting up a plant. And the second of all, the variable cost, that is the transportation cost. Okay. So we have mapped both the costs under objective function. Okay. Now, what will be the mathematical model for the demand? Okay. So for the demand, summation I equals to 1. This will be pretty much similar like the last problem which we solved in session 7. Okay. So I equals to 1 to I equals to 5, Xij Xij is the quantity that we are going to transport from source I to destination j. Okay, equals to dj. What is dj? Demand at the jth location. So this is dj, demand at the jth location, and xij the quantity that we are going to transport from source side to the destination j. Okay, so this becomes the mathematical model for demand constraint. Now, what will be the constraint for the supply? It will be summation destination, that is j equals to 1, j equals to 5, xij xij should be less than equals to KLI. What is KLI? Capacity of small plant at source site. YLI. YLI is what? The number of low capacity plant that we are going to set up at source site. Similarly, plus KHI. That is the capacity of the big plant at source site. And YHI. That is the number of high capacity plant at source site. Okay, so this will be our mathematical model for the supply constraint. And as we discussed earlier also, in this problem, yi can be anything, that is 0, 1, 2, 3, etc. that we have already mentioned here. Okay, so we need to consider the yi as an integer variable and it is not a binary. So yi means yli and yhi, both will be integer variables. Okay, so let us now solve the issue by using the Excel solver. So demand, for demand, that will be the summation of the quantity that we are going to supply. Okay, so here I have mentioned summation B15 to B19, B15 to B19. Okay, just copy this and paste this for all the market. Now YLI and YHI, both we need to find it out. These two also we need to find it out. So this entire part becomes our decision variables. Okay, now what is total supply? Total supply is nothing but the summation of the quantity that we are going to supply from source I to the destination J. That means summation of B15 to F15. Just copy this formula for the entire cell. So available capacity will be YLI, that is the number of low capacity plant at source site, into capacity of that particular plant. Okay, plus YHI, that is the number of high capacity plant that we are going to set up at source site, multiply with the capacity, high capacity of that particular plant. Okay, so here I have implemented the formula G15, that is this one, into G4, that is this one, capacity of the low plant, and number of high capacity plant, that is YHI, H15, multiply with capacity of high plant. Okay, so this will become our available capacity. Now, what is our objective function? Objective function is, we have a variable cost. So in the variable cost, we have mentioned That will be the summation of Xij into Cij. That is cost of transporting from source to destination and quantity that we are going to transport from source I to destination J. So we can mention some product. This is the cost. Okay. Multiply to it the quantity that we are going to transport. That is Xij. Okay. So this will become our variable cost or the operation cost. There is one another cost that is fixed cost. We can mention some product, the number of low and high capacity plant that we are going to set up at source side, and the fixed cost to set up that particular plant. Okay. So total cost that will be the summation of both. That is variable cost and the fixed cost. Okay. So this becomes our objective function. Now let's go to the Excel solver and solve this issue. Okay. So what is our objective? This is the objective to minimize the cost. So here we need to select as a mean. Now what are our decision variables? First of all, the quantity. This is our decision variables. We need to find out the Xij. And second of all, we also need to find out the number of low capacity and the high capacity plant that we are going to set up based on this criteria or the constraints. Okay. So the entire part becomes our decision variables. Let me just see it once. So again, I am selecting my objective function. Objective will be mean. This is our decision variable. Okay, now I am going to add the constraint. Okay, so what is our first constraint? The first constraint is demand. So this one needs to be equal to this one. We need to satisfy our demand. Okay. Now second constraint is related to supply. So total supply needs to be less than equals to available capacity, because we cannot go above of the capacity of the plant. Okay. And the third one we have mentioned the quantity of YLI and YHI, that is the integer variable. Okay. So we can mention this one is the integer variable. Okay. So we have added three constraints based on the requirement. Now let's select the simplex LP. Make this option tick because we do not require any type of negative values here. Okay. And solve this problem. Now see, we have satisfied the demand 12, 6, 14, 16, and 7. That means we have satisfied the demand of the market. Okay. Now, as per the solution provided by Excel solver, we are going to set up two high capacity plant at UAE and one high capacity plant in India. Okay. So total, we are going to set up three plants. And here also you can see the total supply is equals to available capacity. So that is also fine. Now, if we go like this way, then what will be our total cost? The total cost will be 23,120 to satisfy the demand of the market and also to set up the three plants, two at UAE and one in India. Okay, so here you can see for the variable cost, we are going to incur around 5,120. For fixed cost, it will be 18,000 to set up the plants, two in UAE and one in India. Okay, so this is our solution. Now, suppose we are going to reduce the flexibility of this problem. Okay, so when I am saying reducing the flexibility, here you have remembered this for YLI and YHI, we have mentioned this as an integer variable. Okay, so integer variable can be 0, 1, 2, 3, etc. Can be anything. Now, suppose we are putting an extra condition saying that in each location, we are going to set up only one plant. Then what we need to do? Okay, so do one thing. Here I am creating one another column. Number of plants. Okay, so now what we are going to do? We are going to tell the Excel solver that maximum plant which we can build in a particular source will be one. Okay, so let's add that constraint and let's see what is the total cost that we are going to incur if we reduce the flexibility of the problem or if we add more constraints in the problem. Okay, so go to the solver, delete this integer part that is not required anymore. Instead of that, we are going to add, first of all, this one needs to be binary, as only binary values will be applicable as per the constraint that we are going to add. That means maximum 0 and 1 will be applicable. Okay, I am adding this one, and we need to run another constraint that number of plants needs to be less than equals to 1, which I said earlier as well, that the maximum plant for a particular source I, we are going to set up only one. Okay. Okay. So we have added both the constraint. Now click on solve button. Okay. Now you can see as per this additional constraint, we are now going to set up a high capacity plant in Brazil. We are going to set up one high capacity plant in UAE and one high capacity plant in India. Okay. And initially we received a total cost of 23,120, but right now you can see the total cost has been increased from 23,120 to 23,470. So which I said earlier as well, if you increase the constraint or if you increase uh, or if you decrease the flexibility of the problem, then definitely your cost will increase. Okay. So when I am saying the cost, it can be your fixed cost or it can be your variable cost or the operational cost as well. Okay, so that is the end of our today's session. I hope that you have enjoyed this session and able to understand that how we can take a strategic decision to set up a plan based on the constraint, based on the requirement. So please apply this and help your organization to grow. So thanks for listening and have a wonderful day.